Today's lesson is over functions. I'm going to go ahead and tell you that I'm probably going to run through this video pretty quickly to explain everything that you see. So please feel free to stop the video at any time, catch up to what you need to catch up on writing, and then continue from there. So what are functions? Well, function is a relation, or a function is a relationship between the input and output. There is exactly one input for each output. The domain. The domain is a set of all x values in the function. Range is a set of all y values in a function. A continuous function is a function with a graph that is unbroken. And a discrete function is a function with a graph that consists of isolated points. So what is a function? A function is a relationship in which each element of the domain is paired with exactly one element of the range. Once again, please feel free to pause the video and catch up. All right, so there's three main parts to a function. The three main parts are the input, the relationship, and the output. So if we are given the equation y equals 2x, how does input, relationship, and output relate to this function, or this equation? So what we're going to do is we're going to make a little chart here with input x, because your input is your x, which is also your domain. Then we have a relationship. Then we have output y, or range. So if we are going to input a 0, okay, we have 2x, and then you're going to fill in a 0 for x, so 2 times 0 is 0. Your input x, if we're going to do a 1, 2 times 1 is 2. So your relationship is actually your equation. Your y is your answer. So let's think about this. Yesterday you learned about independent and dependent variables. Independent is what you choose happens to the equation. We choose to input a 0 or a 1. It's independent to what we have chosen. But the y, or the range, is dependent because the answer for y depends on the value we select for x. Okay, so that's how independent and dependent tie into this. So if you choose a 2, you place the 2 in for x, so you have 2 times 2 is 4. 2 times 3 is 6. And 2 times 4 is 8. All right, so here's your function: input, relationship, output, and your relationship is your equation. So now let's talk about the function machine. All right, so I have a function machine here. So the function machine is the relationship, or the equation. Okay, so if you input an x into the equation, you're going to get a y. Now, your relationship is what your calculator does. You input the x, the calculator creates this relationship, you hit enter, and you get the y. If you input an independent variable, you get the dependent variable. If you input an input, you get an output. If you put in a domain, you get a range. If you put in a cause, you get an effect. That's what the function machine is. Okay? So now let's talk about characteristics of a function machine. Or characteristics of a function, I should say. Characteristics. For characteristics, each x is paired with exactly one y, and x cannot repeat. So let's think about this. If you're thinking about a function machine, the best example of a function machine is the penny machines that you can get a souvenir out of at the zoo or the museum or Six Flags. You can input a penny. You can turn that crank and you can get a picture of a giraffe or Mickey Mouse or Minnie Mouse, depending on where you're at. Now, if you take that penny, you have to put the round penny in the machine. That's your input. You crank it, and while it's creating the souvenir, that's your relationship, and the output is your souvenir. Now, when I'm talking about x cannot repeat, is you can put a shiny penny in and get a Donald Duck souvenir. And you can put a dirty penny in and you can still get a Donald Duck souvenir. But you can't ever take that souvenir penny and put it back in the machine. Okay? So that is the perfect function machine. You always have to start with a very different round penny. All right? So that's what I mean by x cannot repeat. So let's look at these examples. So let's talk about mapping. All right? So if you have mapping, you have x and y. 3 goes to 0, 4 goes to 9, 5 goes to 9, and 6 goes to 10. Well, this is considered a function because if you just focus on the x, x does not repeat. All right? Yes, it goes to y repeats, but it doesn't matter. You could use a shiny penny, like I said, and get Mickey Mouse, or you could use a dirty penny and still get Mickey Mouse. All right? So the range doesn't matter. It just depends on if x repeats. Now on the next one, we have -3 to 1, -2 to 2, -2 to 0, and 1 to 5. This is not a function because -2 repeats. You cannot put in -2 and get two different answers of 2 and 0. All right? So this is not a function because if you look here, 2 goes to two different numbers. All right. So now let's look at a table. So if you're considering looking at a table, X and Y, we're going to list out the same numbers here, 3 to 0, 4 to 9, 5 to 9, 6 to 10. And we're going to create a relation. Now remember, a relation is a set of ordered pairs. So the only thing we're doing is we're taking the table and creating a set of ordered pairs. 3, 0, 4, 9, 5, 9, 6, 10. And you're going to do that on both tables. Now, is this a function? Yes, this side is a function because x does not repeat. X does not repeat. This one is not a function because the -2 is an x value and it repeats itself. So right here, this is not a function because x repeats. All right? So this is a function, this is not a function. So now we've looked at mapping, tables, relations, or the domain and range. So now let's look at the vertical line test. How can you tell if it's a function if you're not given ordered pairs and you're just given a graph? Well, what we're going to do is we're going to look at the graph and we're going to use the vertical line test. The vertical line test is states if a vertical line intersects the graph more than one time, it is not a function because your x values actually go up. And I'm going to show you that in just a second. So I'm going to go ahead and show you the whole thing so I can explain it. All right, so you have functions over here on the left and the graphs that are not a function on the right. So if you pay attention, the black is just my x-axis and my y-axis. The pink is my graph. So if you go here and you have your graph, that's a U-shaped graph here, the vertical line test says as I move my pen all the way across this graph from the left to right, the graph will only intersect my pen at any given point, okay, one time. So I drew a couple vertical lines. Right here, look at my green lines. It only intersects that green line one time. No matter where I put a green line, it will only intersect it one time. Remember, only focus on the pink. All right? But if that graph is drawn this way, and you draw that vertical line right here, it intersects at this point and this point at the vertical line. So that means x repeats. So this is not a function, and this is a function. On this one, a linear function here, linear line, okay, linear function, linear equation. No matter where you draw a vertical line, the vertical line only intersects the graph at one given point. Now we're just looking at one vertical line at a time because it's like you're moving this across. You put a vertical line there, it only touches the graph once. You put a vertical line there, it only touches once. You put a vertical line there, it touches once. All right? And the same here, when you have a graph that goes all the way across, no matter where you put the vertical line, it's only going to intersect our graph at one given point. Now this one right here is not a function. The reason why is because when you draw that vertical line, it is actually touching every single part of that vertical line. So listen here, listen to this. If you look at this, some students don't understand, but let's say this is at 3, 0, okay? Well, then the next point right up here is going to be at 3, 1. And then it's going to be at 3, 2. And then it's going to be at 3, 3. Oopsie. Let me fix my parentheses there. At 3, 3. So see, when it's a vertical line, your 3 is repeating, okay? Because you would go over 3 and then not move to 0. Over 3, up 1. Over 3, up 2. Over 3, up 4. Over 3. So that is where x is repeating when it's a vertical line, okay? So make sure you look at this. Make sure you understand the vertical line test. It is simply taking your pencil all the way across the graph, moving it from left to right, as long as the graph only intersects your pencil or pen in one spot at any given location, it is a function. If it intersects or touches your pencil in more than one place, then it is not a function. Thank you.